Today we're going to learn the lesson for 9.1, adding and subtracting polynomials. First we have to define the term polynomial, and it's an expression with one term or more than one term combined with either an addition or subtraction sign. Now a polynomial can be split into smaller subgroups, the first one being monomial. If you look at the prefix mono means one, so this is made up of one term, such as a regular number like 5, or it can be a coefficient and variable combination such as 5x, or even have exponents such as 5x squared. Next type is a binomial. Bi is a prefix for 2, therefore we have two terms that are joined with either a plus or a minus sign. So examples could be x plus 5 or 3x squared minus 7x. Next definition is trinomial. Tri is the prefix for 3. So we have three terms joined with a plus or a minus sign. So example could be 2x squared plus 6x minus 2. Now we have to talk about the degree of a polynomial, and that is the sum of the exponents of a monomial, or it could also be the largest exponent sum from a term of a binomial or trinomial. We're going to do a couple examples, one of each. The first type is a monomial, and the rule is you add your exponents together, 5 plus 6, and we get a degree to be 11. The next we have this happens to have four parts, so this is called a quadrinomial, and the first term has a degree of 3, the second term has a degree of 2, the third term has a degree of 1, because there's a little invisible 1 right here, and then we have no x at all, so that part has a degree of 0, and you pick the one that's the biggest, so it would have a degree of 3. Now we have to mention the standard form of a polynomial, and that is when the terms are arranged in order so that the exponents go in descending order. So it would be from the highest exponent of x to the lowest, or if there were more than one variable, it would be alphabetical order. So we're going to write this polynomial in standard form. And because x to the power of 4 is the highest exponent of x, it would go first, followed by the x to the power of 3, then the x to the power of 2, then the x to the power of 1, and numbers always go at the end. So here is that polynomial written in correct standard form. So now we're going to name several examples of polynomials by the number of terms along with their degree. So here is a list of examples. We're going to look at the first one, 4x squared minus 8x plus 9. It's got three terms. That makes it a trinomial. And we look at each part separately. So the first one has a degree of 2. The second term has a degree of 1. The third has a degree of 0. Therefore, the one that's the biggest is 2. Next, we have no plus or minus signs between the terms. That makes it a monomial. And with monomials, you have to add up the two exponents. So 4 plus 6 is 10, giving it a degree of 10. The third, it is made up of two parts. That is a binomial. And x to the power of 1 has a degree of 1. Y to the power of 1 has a degree of 1. You pick the one that's the biggest, and the degree would be 1. 5 is just a regular number. They are always monomials. And because there's no variable at all, it has a degree of 0. This next question is kind of tricky. Because they both have x to the power of 2, they are like terms, so you would have to combine them first. So 9x squared minus 5x squared is 4x squared, and that makes it a monomial, and because it has a power of 2, that gives it a degree of 2. The next one is two terms that are completely different. That makes it a binomial, and now we have to look at each term separately and pick the one that's the biggest. So 9 plus 5 is 14. 6 plus 7 is 13. 14 is bigger, therefore its degree is 14. Negative 10x is one term, making it a monomial, and x to the power of 1 gives it a degree of 1. The last one here is four different terms, therefore it's quadrinomial, and the first term is degree of 2, second term degree of 1, third term degree of 1, fourth term degree of 2, You pick the one that's the biggest, and degree is 2. Now, polynomials can be added or subtracted two different ways, either vertically or horizontally. Using distribution, we are going to do examples of both types. So the first, we're going to use the vertical method. So here I've got two different polynomials, and we're going to add them up vertically. So when you're doing that, you have to make sure that you line up each of the terms in its own column. So x to the power of 3's are its column, x to the power of 2's, x to the power of 1's, and then the numbers get lined up as well. Now, it doesn't matter which order we add them all up. There's never numbers carried over to the next column, so you can start at the back and work forward, or vice versa. I'm going to start at the front here. So 6x cubed plus 2x cubed is 8x cubed. 9x squared plus negative 5x squared is 4x squared. Negative 5x plus 3x is negative 2x, and 1 plus 8 is 9. Now we're going to subtract. Now notice in this first one, we're missing an x squared, and there's an x squared over here. And then this one is missing an x cubed, but there's an x cubed there. So you do have to allow for those missing parts. So when I write it all out, where it's missing, I add a 0 of that amount. So here I've got a 0x squared, and for the bottom one here I have a 0x cubed because those are the ones that are missing. And I'm subtracting. So 8x to the power of 4 minus 5x to the power of 4 is 3x to the power of 4. Negative 4x cubed minus 0 is negative 4x cubed. 0x squared minus 2x squared is negative 2x squared. 8x minus negative makes plus x is 13x, and 6 minus 3 is 3. And it is in standard form already, so that is a correct final answer. Now we're going to use the distribution method. Here's an example. Now whenever you have parentheses, you always assume that there is a 1 in front. So here I've got an invisible 1 in front here, I've got an invisible 1 in front here. I distribute the ones in. Now because of the plus sign, all that happens is the parentheses go away, the signs all stay the same. At this point, I'm now ready to add my like terms. So 8x squared plus 5x squared, I'm adding those first because they have the highest exponent of x. So 8 plus 5 is 13x squared. And then negative 6x plus 1x is negative 5x. And then numbers go at the back. So 2 minus 9 is negative 7. Next example, now here I've got a negative in front of the parentheses, so there's actually a negative 1 that has to be distributed in. And over here I've got another negative 1 being distributed in. So when I do my distribution, I end up with this step. And now I add like terms. Negative 5x squared minus 2x squared is negative 7x squared. Negative 9xy plus 8xy is negative 1, or just negative xy. And 7y squared plus 2y squared is plus 9y squared. And for this one, we've done questions like this earlier, remembering that the word from always goes first. So I'm going to take this polynomial back here and subtract the one in front. So here they are written out. And there's a 1 in front here that would be distributed in, a negative 1 here being distributed in, and I end up with this long polynomial. And you always have to end with adding your like terms. So 8x cubed has the highest exponent, so it goes first. And there aren't any other x cubes, so it just carries down. Now you deal with your x squareds. So 6x squared plus 2x squared is plus 8x squared. Then we have negative 5x minus 9x is negative 14x. And 7 plus 3 is plus 10. And for homework, we're going to do page 430, number 22 through 27, and 31 through 49. And that is also, thank you for being in my class today.